You get to hear a little bits of it again, but it's a little more structured. I got asked to do a brown bag, and I was kind of like, I don't know really what to talk about or what people might find interesting. My title is architect. I'm really a software developer. I've been doing it for 30 years. If you want to ask me how much better it is these days than it was when I started, you can come and talk with me over beer about it. I'm a cyclist. I'm a dad. I love my little man very much. This is a photo of him when he was about 4. He's still just as cute, but he's not as little. I'm a cook. I like cooking. Around Christmas time, my son and I, we will make biscuits and cakes and package them up and give them to people. I'm an author. I've written 3 or 4 books. I'm currently writing another one on cryptography. So if you need a book to go to sleep to, I can hardly recommend it. It's on Lean Pub. You can go get it. Lean Pub's really great. For these books that I wrote, you got given an advance. And the amount of hours that you spent writing a book, I would have been better off going and working at McDonald's. You know, it's not worth it, the amount of time you spend, but it's a lot of fun doing it. Lean Pub is much, much better. The amount you got per book, kind of traditional publishing, is about $1. And the amount that I'm getting at the moment for the Lean Pub stuff is around about $15 to $20 a book. So yeah, it's a huge difference. There's a big change in the publishing lifestyle. Speaker, I've spoken at lots of events over many years. This is a little bit old, but it was in Yale 2015 when I spoke about microservices. I thought about talking about microservices today, but I didn't want to depress too many people. It's not a topic I'm a huge fan of. I'm a software developer. In my spare time, I write cryptography software. So yeah, I'm about as exciting as it sounds. This has been going for rapidly heading towards 20 years. It's probably one of the longest serving open source projects still in existence and still under active development, maybe apart from the Linux kernel. We have a Java and a C# version, and we have a FIPS, which is the Federal Information Processing Standard version as well. So if you need to do crypto for the US government, you can use our stuff. And most importantly, I'm a husband. My beautiful wife Jo, who lets me come and visit New Zealand. At work, I'm very much a coach and a mentor these days. I don't get as much opportunity to write code as I'd like, and that quote comes from Kent Beck, which I think is pretty adorable. And I'm pretty much easily excited about everything. So I wave my arms a lot, I get loud, I have lots of opinions. I'm not always right, but I enjoy having conversations about nearly everything. So I'm going to talk about a couple of significant anti-patterns that I see in software development and software delivery that's kind of crept in a lot over probably the last 10 years or so. I'm not saying that all software prior to 10 years or so was perfect, but we're seeing a lot of things happening in the space that's actually making life a lot harder. Glad you can make it, Mark. Do we need to buy you a watch, or you're okay? It's Apple Watch, okay. And it's mostly around testing. And see, I told you, you come in at the back, you're going to get sledged. Testing and continuous integration and this thing called CD. And I'll talk a little bit about that in a moment. I have one main group of people to blame. They're ThoughtWorks. How many people here know who ThoughtWorks is? Heard of them? Yep. I used to work for ThoughtWorks, so I'm kind of partially blaming myself. They're a consulting company that's kind of made their money out of selling Agile and selling software processes. And it's pretty much cargo culting in the extreme when it's applied in a lot of organizations. So the ideas are right, the application's not so great, and this is where we end up with a lot of the anti-patterns that we see. So I'm going to start talking about testing. And so these are the kind of 3 main groups. I don't know how easily people can see that. I chose poorly with the colours with the MYOB slide deck. So we're talking about testing. So TDD. So who thinks TDD is about testing? Hands up? No? No one? Yeah. Or no one doesn't want to participate? Put your hands up if you want to participate or not get sledged. Come on. Yeah. Okay. No, it's not. TDD is about design. Unit testing and integration testing. And then we've got this thing called BDD. How many people know, use, heard, work that way here in Auckland? Yep, okay. So what I'm really going to talk about is this main thing in the middle. TDD is not testing, TDD is design. But that's a topic for another brown bag that I'll do next time I come back. BDD is almost universally poorly done, and it doesn't mean write your tests in Cucumber, which is pretty much what it kind of has meant to me. People laugh, but yeah, I went through a couple of crews in Melbourne, and they're a C# shop, and they're going, oh, we need to build all our functional tests in. And I go, what are you people doing? And it's like, we don't know Ruby, we don't know any of these things, and they're learning this to do it. It's like, just write them in C#. Can we do that? Yes, you can. You can. So historically, people do this really badly. It's really slowly. Again, a topic for another talk. I'm going to talk about unit testing and integration testing, which is the things that I find people do most poorly, and it has the biggest impact on your software development cycles. So this is a fairly typical piece of software that we might want to write. We've got some processing component. We want to pull stuff out of an S3 bucket. We want to use SQS to get stuff in, and we might want to send notifications out. It doesn't matter what the technology is, but these are like external things to your system. We agree this is something that we mostly write? Yep. People at the back? Yep. Can't talk, Mark? Mouthful? Yeah, okay. So, how do we go about building this software and testing this software? What do most people do? We be very quiet. We don't test it. Do we not test it? We do. The silver bullet. The vampire's dead. Okay. We can use TDD. That is an approach, but that will help inform about how we might test these things. But before we TDD, we lather the magic TDD on things. How would we think about testing these? Yes, please. Mocking. Well, that's a good one. Jason, what do you think about mocking? Jason's not happy about it. You've made Jason very sad. Anyone else? We can do that. That's an important thing. But there's probably two types of testing we want to do here. We want to test if our processing component works in the way that we think it did, and then we want to test whether or not the actual things work in a way when it's deployed in the real world. What happens if the S3 bucket is not available? Those sorts of problems that we have. So normally we'd build some unit tests which would test this, and you are correct, most people are then going to do some kind of mocking, probably using some mocking library. Jason then gets very sad. Yeah, and Ken gets very sad. So Ken Scambler is now working for MYOB. He used to work at REA. He's given a whole bunch of really great talks on mocking. I provide some links to those in a sec. You should watch them, they're awesome. Ken is awesome as well. You should hassle him on Slack, and you can say that John said you should hassle him on Slack and say, everyone when we've finished, go out and send messages to Ken. And so, how we'd go about testing these, we'd build some CloudFormation, we'd do some things like that to make it all work. So, this is pretty cool. So, this is what ends up happening with our development process for it. We've got our developer, we chuck it into Git, we have our CI server, we run our unit tests, we package it up in some meaningful way, we run our integrated tests with SQS and all the rest of it that might be in there. And how long does this take? Yeah, 20 minutes, 30 minutes. Is that a good thing or a bad thing? Yeah, it's not probably a bad thing. It most certainly is a bad thing. But more importantly, why is it a bad thing? Yeah, feedback too late is one. The other one that happens is that the whole idea of doing this cycle of testing was that you're only meant to check in when the light is green. How many people do that? Only check in when it's green. So orange is when the build is running and red is when it's broken. So no hands? Yeah. So it's really, really hard to do good software development unless you're following that practice, because you end up with a bunch of broken software and you don't know how broken it is. So one of the main components of building good software is getting your feedback loops, especially in software development, as short as possible. So people take that on board, and this is kind of what happens. That we end up in a situation where people go, hey, it's these integration tests, or integrated tests as I like to call them, and JB Rainsberger talks a lot about the difference between integration and integrated and the terminology. It's a little bit a little bit fuzzy, but a lot of it comes from the fact that hang on a sec, Eduardo, yeah. A lot of it comes from the fact that we don't really have good nomenclature around what to call tests and the units of tests. And there's probably been discussions about tests and what to call a unit test and what is a unit, probably been going on for, I don't know, 30 years. So I'm going to make some definitions as we talk about this stuff, but at the end of the day, when we talk about integrated tests, we're normally talking about components, talking to other components over a network of some form or another. So that's the definition I'm choosing to use. Sorry, Edward?
That was my question.
Okay.
You're talking about integration tests or functional testing with real world systems.
Yeah. So in general, we look at integrated tests are some kind of stand-up in some kind of real world. And so we do this, and it's the 20 to 30 minutes. So what do we normally do to solve this problem to make it faster? I've seen that happen, and that's kind of exciting too. I've seen 2 to 3 crews of people trying to do build engineering on trying to make builds run in parallel. At REA, we had some amazing infrastructure written by very smart people over many years, purely for that. It was wasted effort, but it was an amazing piece of infrastructure. Mocking's the other one. It's the classic thing we'll do. We'll get a Makito, and we'll do all of these tests, and then all of a sudden our stuff actually looks a lot faster. And this is what our code tends to look like at that point in time. You have some mocking framework that does this. So I'm now going to talk a little bit about mocks and why I talk about them in the way that I do. So there's a concept around when you're doing testing, and TDD is a driver for this, called test doubles. Have people heard that phrase? Yep. So mocks, stubs are the 2 main kind of concepts that are involved in that. And I propose another term to use as well. But for the purposes of this, test doubles are a good idea. Mocks, the general concept, are a good idea. Mocking libraries are a bad idea, and stubs are a bad idea. So mocks, the actual concept which is that you're providing an alternate strategy for your system under test. So this is the thing I want to test. But an alternate strategy for that is a really good idea. You're getting rid of your dependencies, and you can actually do your testing quickly. What tends to happen though is that when we fire these up, the confidence we have in this working is now dependent on how good you've thought about your mocking. Does that make sense to people? Yep, so what ends up happening a lot in mocks, and even in the general testing frameworks and guidelines that you get for using mocking libraries, I did some research and looked at this, and Makito is a good example. I don't know how many people use Java here, but C# has similar ones. They suggest, expecting certain sets of data coming out of your thing, so that I might have a chunk of I might have a database, and I expect when I read from my S3 that I'm going to get some data coming out of it. And my test will pass because my mock will be set up to return that data. That pattern familiar to people? Okay, yep. That pattern creates a lot of coupling, and that pattern makes our tests very brittle. I'll explain about that in a sec. So we're at a point where we've got these. So we now want to look at this is, well, as I was saying, this is kind of like a normal Makito style test. So we've got some processing component, and we use the libraries part to actually do reflection on the classes to do that. Do people use mocking libraries here? Yeah. What do we use? What do you use?
Just has a mocking.
Okay. Yep. And they all work similarly to this. Yeah. So this is an anti-pattern in testing, but it's exacerbated by the mocking libraries, is that we actually don't ever want to test data. And testing data is a really dangerous thing to do, because my code here is working, if you like, with my tests. And if you imagine a perfectly working piece of software that does that, if I wish to change my language from English to French, this test is now going to have to get changed, because I I don't le data. I don't know. My French is not so great. But the approach for doing it, means that I've now coupled my test behaviours or my test implementation with my own implementation, which means that if I change what happens in my systems, I have to change these tests. But my code, if I change to French, will actually still be really working, but my tests will fail. So we're actually getting our tests telling us the wrong thing. Does that make sense to people when I say that? So this is a pattern I see all the time, where people will test actual values as part of their code, and you really never, ever, ever want to do that. That is the thing we want to break. And Edward and I had a conversation on on Slack that you can probably go look up at some point, which was about why I don't like mocking libraries, but I do like mocks. And the short answer is it makes it really, really easy to do this, and you end up with a bad pattern out of it. Your testing of your components and your system under test should always test behavior. So what I should be doing as part of this is literally test to see whether the get data method was called on my component. I don't actually want to test which a lot of the mocking libraries will provide you the capabilities to do as well, but it's very easy to end up with stuff that looks like that. So I'm going to flip a little bit back to our system. So we're now at a point where when we used our mocking tests and things like that, we end up getting faster feedback. So one of the things that we had the problem before was those integration tests that were running as mocks that we like to use, or our integration tests, actually don't bias a lot because it's not actually running in the real world. And I had this conversation with Alex M in the IDAM, I think it's IDAM, the tribe crews that they're working with. I don't know the name. Do you know it, Jay? No. Someone will correct me at some point. And they're doing SMS authentication for customers. So you've got 2FA. And how do you go about testing this? And he's like, well, we can mock this biz out. We can provide a stub. And it's like, why? Why are you doing that? What's the value that you're providing as part of that? That you're actually just writing a whole lot of code that's not really providing you any additional confidence that your system's going to work because you're not actually deploying this into the real world. So that's probably the biggest problem with using things like fakes and mocks inside your system test environments is it doesn't actually help you get any closer to success because you can't say my system will work when it goes into production. You might have marginally more confidence, but then what you end up doing is, and again I've seen this happen a lot, is people will invest a lot of time and energy and effort into building very large, very complicated stubs that pretend to act like the real thing. And unless they're bug for bug compatible, they won't even work. So I presume we do that here as well? No? Do you have any things you stand up that pretend to be something else? Yep, okay. You probably want to just throw those all away because they're actually not doing what you think they're doing. They're not actually helping you write any better software. And so JB Rainsberger talks about this. Go and read some stuff that he's done about integration tests being a scam. But I suppose the question, yes, Andy.
So you mentioned never test the data, but even if you're testing that you call a certain method on a certain
Yep.
things, that often kind of binds you to the implementation and causes brittleness as well.
So you're binding to the contract. A method signature is a contract. So if you change the method signature, you want your tests to fail.
That's if you, but I see a lot of code where they're injecting just their own classes and mocking their own classes.
Yep.
And so you're sort of binding to your internal implementation. So if you want to change the way that you work out X, suddenly, because you're not using Y component over here to do it, you test break, but you're still using X.
Without seeing an exact example of that, I don't know. I can't answer that easily, but the short answer should be that shouldn't happen. And
At the end of that test, then verifies that method was poked. It says verified on the mock that you poked this method. It's not giving you.
No, yeah, that's what I mean. It's
Yeah.
like it's just
that is behavior of the class under test. So,
Actually, it's a dependent class.
yep.
So I've got a mock that I'm going to give to the thing that I want to test. Test it, drive your method that you think is going to invoke this other method on this other class. So your tests become aware of the implementation of how it actually gets the result, and then you make sure that the result matches with an assert, and then you verify that it got that result by poking this other method on your mock. And that's it's an extrapolation of the previous slide that John was testing with the processing method.
Generally what you want your tests, your classes under test, code under test, unit under test to be doing is testing the behavior of that, not of the other things that are its dependencies. So if I've got generally the sorts of tests that you're thinking about is how does my class under test behave when I get no list elements come back? How does my class under test behave when my database throws an exception? Not how does my class under test behave if I've wired up the string which says some data, do I get that some data? Because that is not a useful thing to want to know. Yes?
If that some data is being transformed, right, in a way.
That's a different test. That's not the job of this class. I would unit test the class that's doing the transforming. So you would have an object which is a transformer, and I may test that. I may unit test that in a meaningful way. Let's say I'm flipping the first and second characters in there. I would test that to see if it works. In the same way that unit tests of algorithmic things, we might have a run sheet of tax calculations to test those. But those generally do not have dependencies. They are testing an algorithm. And most of these things I'm talking about are the anti-patterns that occur when you have dependencies, especially external ones. It happens with internal ones as well, but it's more pronounced with external dependencies because of the accelerating anti-patterns that occur, if you like, as part of this. That tests with the external dependencies become very slow, so people do things to try and make them faster, which generate, if you like, don't give you the confidence you need to make sure that your systems are going to work in production. So yeah, you absolutely need some unit tests which test values, but they are the tests for the base level. They are your algorithms. Do I add these two numbers correctly? But that's literally testing that. In this, it's now gone. In the class that's under test that might be taking a calculator, for example, I'm not going to test the values out of that. I'm not going to say, give this thing that I'm passing into it two numbers and make sure that it has added it correctly, because that's not testing the class under test. Does that distinction make sense to people?
That means you mock that calculator.
Sorry?
That means that you'd mock that calculator when you...
Yeah. So that calculator, and so I talked before about mocks. I like the term alternate. And because I want to provide an alternate implementation of it. Because these alternate implementations don't have to be a mock in the sense that they're not doing anything useful. So I'll talk a little bit about that in a second, about why I like that term more. Because for me, mock has a historical meaning of providing data. And the interesting thing is you don't actually want that for the most part. So
One of the things that happens when you start switching from mocks to test your class under test is that you find that class now needs another thing on its constructor because it's doing some more. And more of those, you go, oh, that's easy, I'll just add another mock. And here's a mock field, and I'll only put an expectation on specific tests. But the class that you're trying to test has now got 5 constructor parameters, and it's trying to do far too much. And your tests become more and more coupled to the implementation of your mock classes, or the mocks that you're using to test that dependent class and its dependencies. And so the more and more mocks that you've got, the worse your design is going to be, because you're trying to do too much.
Is by testing get data, you're actually testing the implementation. Like you have a class that has a responsibility, right?
Yep.
And the responsibility is to do something. That's what you're trying to test, right?
yes.
By testing get data, the actual function is called, like that doesn't enable you to change how that
Correct.
cheaper, so you're still putting yourself through.
No, the contract is getting data. I'll talk about this in a little second, and I think this is a really important distinction. When I'm doing my unit tests, and I didn't make this very clear, so I apologize, but all of my tests, this is the class that's under test, this processing component. I'm testing, can I grab something off an SQS stream?
How do you do that? Doesn't matter, right?
Yeah, but this is my function. This is my functional goal at the end. Is that I'm going to get an event on a stream. I'm going to read something based on that, like maybe an ID off it out of an S3 bucket. Maybe it's a configuration file. Maybe it's some data. Maybe it's a document or something or another that's going to come off S3, and I'm going to send it out via SNS. That's kind of what my customer wants me to do. So the testing is about this. I want to test that under the circumstances that I have, does my flow of control in there work as I expect it to? And part of that processing might be adding up all of the numbers in a spreadsheet in an S3 bucket. That might be part of what this processing component needs to do. I haven't added that in there because it's not particularly relevant to it, but there might be something complicated happening in there. But what I'm interested in doing is making sure I don't have these external dependencies as part of my testing, the unit testing that run in my CI. So I'm going to talk about CI, CD, anti-patterns in a sec, so we'll park that, but this becomes an important part of that. Does that make sense? Yeah, go for it.
So, one of the things you need to do to isolate yourself from the external components
Yep.
is to never propagate that external data internally within your domain models. You need to have clear boundaries.
Yep.
The external system talks to a boundary layer, and that boundary layer translates it into your internal domain model.
Yep. Yep.
And if you're doing that, then your internal classes under test shouldn't really know that external systems
Correct.
exist.
So that is a great intro, because we end up with a system that looks like this. And how do we go about designing and building our systems, and why don't we do it right? It is hard. Okay, is the short answer. It is really, really hard to get this kind of right. So I'm going to talk a little bit about it. So that original diagram, I've done a bit of kind of analysis on, and as Edward says, this is actually what it really looks like. I've got some kind of request coming in, I've got some data store, and I've got some output. And they are the logical components of my system, which leads to something looking a lot like this. So I have a part of my system here, which is the request processor. And all it's going to do is call next. This is the contract. So that's, this is my boundary. That's my interface, my contract with the outside world. I'm just going to call next. It knows nothing about SNS. It knows nothing about anything else. And so why is this powerful? Anyone? Help me. Exactly. It doesn't. This processing component knows nothing about the implementation. It's completely agnostic. I can have an SNS one. I can have a database one. I can have a million monkeys on a typewriter one. I can have all of these different implementations of this, and this processing component. All it knows that if it calls next, it will get a request. That's the rules of the game. So I'm actually only just going to talk about request. You can imagine the other couple being in there as well, but there's lots of bits in there. So what we end up doing is, how do we go about testing it? Again, this is our system under test. What do I want to provide it? So I've written an alternate here, which is a collection-backed version of this. So this basically will take a collection of the requests, and when I call next, it's just going to pull it off the collection and give it to it. So I'm in a great position now to do that. And I haven't needed to use a mocking library. It's really cool. My system under test actually has this component, which is an alternate. And one of the reasons why I really like the phrase alternate is I've actually built real-world systems that have run, especially in, if you like, SIT environments and customer acceptance environments that look like this. And this alternate actually provided me a means to deploy this and get customer feedback without having to wire it up to everything and make everything work. And so I could selectively wire up things that are complicated. So has anyone here tried to put stuff into production without having IDAM wired into it? It's pretty much impossible. This is literally how you solve this problem. You have a boundary in there which talks about the authentication requirements of your system, and we have a provider which potentially always returns true. That's it. So we're in a situation where we can actually deploy some feature into an environment which is normally hostile to integration, but we have to write our code to support that. And again, another reason why I don't like mocking libraries, this is a very hard thing to do with a mocking library. The other tests that become really useful and really powerful with this is, for example, if I've got a workflow in my processing component that this might throw an exception in, how do I go about building that? How do you test that in the real world, that your request engine does something unexpected, raises an exception, returns an error? I can actually just build one of these that every time I call next, all it does is throw an exception. So I actually can implement the behavior of the thing that I want so that my system under test, I can check to see what happens. And I might check to see that the return value of this processing component is to return an empty list out of the processing component, or it might return an error response or something or another. I haven't defined what this looks like. But by being able to vary this based on my tests, so when I build my unit tests, I will build a number of these as part of it. And I think Edward, our conversation was, you can use a mocking library to do this, and you absolutely can. But I generally find that that escapes out into the wrong sorts of testing, rather than actually testing the right sorts of things. And then we now can go and implement an SQS version. So this is kind of, if you like, my real world version of it. So the interesting part of this is that this allows me to wire this. Notice I've actually changed here. So this is my processing component. So what I'm actually doing here is going, how does my processing component work in the with my testing components, if you like? The converse of that is, what confidence do I have it's going to run in the real world? So I do, if you like, the opposite. I actually write the real world thing here, which is that one, or this part here. Oh, sorry. And I actually will write some contract tests here which will drive this. And this enables me to see how this is going to work in the real world. So I will set up, in SQS or an S3 bucket or an SQS endpoint, and I will read it. And it is a real world test of what's going to happen under those circumstances. But what that's enabled me to do is go, my processing component works with my alternate, and my real world stuff works with my contract test. So I've got both ends of it covered. And I know now, and I'm very, very high confidence, that when I wire this in to my processing component at runtime, it's actually going to work as expected. Does that make sense to people? So you actually end up with tests doing different things, and you're testing the right things at the right places. Because what I see happen a lot is people try and do this with integration tests or integrated tests. And this again doesn't obviate the need for having, stand up the full system in a real environment and run some functional tests on to make sure that it actually works as our customer expects it to.
So with this example, do you actually have to set up whatever an SQS queue?
Yep.
You actually got a test, like you are doing an integration test with part of your system?
Correct. That's exactly right. Yep. But it's very controlled, and I'm testing this processor, but I'm not trying to do some magic fake testing with it. I'm actually testing it against SQS. I'm actually doing it that way. And so when we went back to BDD and using Cucumber, a lot of people will do this sort of stuff in a slightly different way using Cucumber to do it. And this is why if you just use your native language, it's much, much easier. You write all your contract tests as behavior tests, if you like, against the real world. So I create an SQSQ, I add 3 things onto it, and then I try and pull those 3 things off. They're my tests to test whether this component behaves in the way that I expect it to. Not my processing component. That's the business logic of my world. This is the interface to that world. So yeah, absolutely. This is a functional real world test. You may even do this in production, depending on what availability you have to be able to create or destroy various parts of your systems. What do we think? Oh, absolutely. This is slow. But this is not a unit test. I don't run this as part of my CI, because this is only going to change when. So the breakage models are different. Actually, it's an excellent point. Again, something I didn't articulate. So the value that these provide are triage for when my system's not working as I expect it to. So this is saying my code works against SQS at a particular point in time. And this is one of the interesting things is Amazon will update and change SQS, and all of a sudden your system in production will just stop working. And you go, oh, wonder what happened there. And you run all your unit tests and they all pass. And then you run all of these mocked integration tests and they all pass. And now you have no idea why your system doesn't work at all. If you have these contract tests, I run them against the real world, because that's actually what I'm using. This is talking to a queue or S3 or a database or whatever it is, and this is actually running against the real world, and they will fail because something broke in SQS or they upgraded an API or something and didn't tell you. I stumbled onto this pattern early on in my career when I was writing telecommunication device drivers for telecommunications hardware, and they were provided by a company in Denmark. And they would go and update the firmware in these things without actually telling anyone. And the monitoring software that I wrote would break. And so my boss is on the phone going, John, why's your shit broken? Oh, worked yesterday. Red alarms all the way through Telstra. And it's like, yeah, okay. So I started building these to give me confidence that my software works as expected, because that's what my unit tests do. And this gave me the knowledge that at the point in time, if you like, I had both ends of that. They go that way into my processing components, and this goes this way into the real world. And I could tell what breaks. So if the real world code breaks and I check it out and run my unit tests and they're broken, shit, I've pushed something live that was broken somehow. But conversely, if I run my contract tests, that gives me confidence one way or another whether the real world has changed since I last did my things, because this is the binding of those assumptions about development. Yes, Mark?
So John, I've seen a similar pattern in a previous organisation. We actually identified them as monitoring tests.
Yep.
And we had them running at a different test run at different cadences.
Yep.
So it wasn't just on demand, it was at a regular.
Yep.
Was that how you?
I have traditionally run these daily. It's like whatever I might need to do. Generally, they are used as an on-demand test because that's kind of how it works. The big advantage of having these is if you get into beta programs and things, you can actually take all your contract tests, point them at a beta environment and go, what needs to change in my environment, or what do I need to schedule in my next sprint to make my code upgraded to work with the new version of the software. And so these might talk to SQS, but this also could talk to a third-party library that you're using. Is it safe to upgrade to .NET Core version X? Well, I can run all these tests that are talking to those things, and you will actually be able to know that ahead of time. So that becomes useful as well. So these become a very useful set of tests, and I would, strongly recommend using your normal development languages to do that in. I'm going to move on, because I've got 15 minutes to do the remaining half of the things. So there's some things. A lot of this is about designing stuff properly, designing the interfaces and understanding what the systems under test you're testing are. Don't test data, test behavior. There's some things about it. I actually have a fully worked example in Java that's available that you can have a look at in the code and everything for that. I'll make this available online. People can keep and grab it, Chris. So the person that's worthwhile looking at in the real world is Gary Bernhardt. 2 awesome talks that you should go and watch if you haven't seen already. Fast test, slow test. He doesn't like so much the idea of kind of like unit test and functional test. I kind of like this difference as well. I like fast tests and slow tests, and that becomes a good indicator because in software development, actually doing the development, you want fast tests. Slower tests are okay for other things, and we shouldn't always try and make slow tests faster. That's again, another pattern that we probably don't want. And boundaries, which is a really, really, really great talk about how to structure your software components so that you can test them well. So I'm going to talk about CI and CD. So we're going to have to lock that door because it's going to take longer than 15 minutes. So CI, CD. These are an interesting set of concepts that originated, the CI part originated in about 91. I think it was Grady Booch who first came up with the idea of it. And he in fact documented it as part of his methodology, the Booch methodology, for if you're old enough to remember. And it was relating to how to write OO software properly, talking about continuously integrating. And I'm not going to say what the D is just yet because this is probably part of the really interesting things about this is. So I've got continuous integration. It's the practice of merging all developer copies to a shared mainline. There's quite often a lot of discussion about trunk-based development or how you do it. I am a huge fan of everyone working on trunk, but it actually doesn't matter. If you're a development team and you've decided to branch and your release branch is going to be that for a period of time, and everyone's on that, it's kind of your trunk for that sprint project process. There are some other issues potentially with doing that, but continuous integration is all about everyone on that team sharing the fastest feedback you can possibly get while you're doing software development. Make sense? And then we've got the D bit, and it either can mean, depending on what you want to say, continuous delivery or continuous deployment. And it actually makes a huge, huge, huge difference what you're talking about. And I think in a lot of ways, this is the biggest misunderstanding about doing the CD side of things when we see it. We see a lot of people doing and thinking they should be doing continuous deployment, when in fact, I believe we should really be striving heavily for continuous delivery. And this is a developer structural mindset thing, and this is a tooling thing. There's a mindset that's associated with it as well, but primarily the differences are quite stark about what you want to do and how you want to go about doing it. So really with continuous delivery, the mindset is the code that is on master is ready to deliver at any point in time. Continuous deployment is every single change I make gets deployed. And this is often very, very dependent on your organisation. So and I spoke with the practice people or the partner people on Monday about this, in an organisation like ours where we've got a very conservative group of people, which are accountants, pushing every single change to them every day or every minute, even if it was possible, even if we could get to that point, they're going to hate us for it. They absolutely hate us because shit be changing. And it's like, and it's funny, I can also make fun of accountants because that's actually my degree. I have an accounting degree, but now you all know that I'm going to have to kill you. But yeah, so that's they don't like change. It's an organisation, and more importantly, they're using our software as a tool to do their job. If their tool is changing all the time, hammer, screwdriver, saw, what is it today? It's never that broad, but buttons moving and things like that, every time that happens, we might look at that as an improvement, but for them it's actually a change and it's a cost to them. It's a cognitive load to change. I worked at ANZ for 6 years and we developed the telling software that went out to all the branches. And when I was there, I was one of the teams, but helped champion getting the bank to be agile, the retail part of the bank, i.e. embracing change and embracing faster releases. And it would take, we could release very quickly, but we didn't do it because it would cost between $1 to $2 million each release in training the tellers about the changes to the software that we just made. So this has a lot of flow-on effects that are relating to your business. This doesn't. So for the purposes of what I want to talk about for the rest of this is what I think is really important. Continuous delivery. This is a mindset and this is an approach to software engineering that we all should have, that the things we're working on should always be able to be released. Whether we do it or not, that's a different thing. What do we think? Yes? Go on, Edward. You wish to disagree, please do.
Is there a middle ground for doing, so every change needs to be deployable?
Yep.
You're deploying every change to, say, development every single
Yep.
time. You're proving that you can do the deployment.
Yep.
That
You are.
as well. So to production, that's very dependent on business. I mean,
Yes.
Obviously, there's lots of businesses out there, they are the customer. You don't want to push them changes all the time.
Yep.
If you're running a social network or something, the people using the system aren't the customers, the advertisers.
Exactly. Yep.
It's completely different.
Absolutely. This is very dependent on your business, and I hope I will answer your question by the end of this. Is the short answer. So I'm going to talk about this. So I'm going to start about talking a little bit about CI, because this is probably the thing I care most about. So the CD part of the equation is a horrible anti-pattern because it drags us in the wrong direction. For us to be effective, and that's probably most of the people in this room, except for Mark, I don't think Mark actually continues to write software anymore. Everyone here still writes software every day, don't they? Except for Mark. Yeah, see, there we go. It's like, you can see yourself out, mate. That's the thing that makes us go quickly, okay? Sharing our code and doing that. So originally, this is what we did, except we didn't use Git. We had other things that we used, and we had 2 developers on there. Working in a team of people, who's worked in an environment like this without CI? Well, I have. Yeah, a lot of people have. Goodness me, you don't look old enough to have suffered in the way I did. What was the most common phrase you'd hear while doing this? Yeah. Correct. Actually, Chris got it. It works on my machine. The number of times, I used to joke, I'll put that on your gravestone, or tattoo that on your forehead, because the number of times you had a situation where someone had updated a library locally, did something, management, you had no idea about the code that you've just pulled out, and you run some tests and it's red. Red meaning your test might break. It didn't have to be a CI server. It's broken. Is this the changes I've just made, or is the shit that I just pulled out of Git broken by, not due to the negligence of someone else, but just due to being a human? So what we actually did was we actually had a PC that sat over by the side there, and once a day we would run it. We didn't release as often, and in fact, interestingly enough, this is the model that Grady Booch talks about as well. Not continuous integration, but frequent integration. So this was kind of like a gatekeeper in that. So the first thing you'd do when you came into work the next morning was, you'd check the status of this to see whether the actual state of the repository was valid or not before you could start work. And we'd do a lot of the things that you'd see now happen in CI, which is to clean that up before you started doing any actual work. So we got feedback that way. We didn't have CI servers. So CI is really all about for the developers. That's really what it's all for. It's to provide you with the confidence that you can write your code and the new pieces of function that you've got and run your unit tests. And any time that it goes red while you're doing that, that is your fault. Mostly Jay's fault, but not mine, but it's your fault for it happening. So you can fix it. That's the entire purpose of this, is that you're getting this feedback. You've got this independent third party going, Yep, that works. That works. And, the environment that you've got set up and the way that you've done it means that it is safe for someone else to do it, which gives you great confidence to move quickly. Okay, you're not second guessing yourself, you're not backtracking, you don't have 200 or 300 lines of code that you've just written, and you don't know whether or not it's broken, or it's broken some other part of your system, or Chris broke it on me. Yep. So that's why it's there. It's to let us know that. And to me, that's the most important thing. And this is why unit tests and those things have to happen so quickly. Because you want that feedback to happen quickly, because you are limited by the number of check-ins per day based on how quickly this can go. Because if you check in on red or orange, then the whole thing falls apart anyway, because you're no longer paying attention to the feedback and the code you've just written may or may not be broken. All make sense? And this is why I care very passionately about unit tests running quickly. And that's why we talked before about testing properly, because you can actually have really comprehensive unit testing suites and have this happen quickly, and no mocks and no integrated tests, and have this whole thing happen in a couple of minutes. I mean, ideally, your unit test suite, when you run it locally on your machine before you check in, that should happen in seconds, 10 to 20 seconds. If it takes longer than that, fix that problem. Fix that problem first, because without that, you can't get any faster and your software will not get any better. So CD, in our case, is delivery for the customer. This is really what I like to do it. It gives them the confidence to know the release is ready. Yeah, so we've gone from the point of going, hey, CI is all about me knowing my code is working correctly, i.e. the code I've built and the tests that I've got around that give me confidence that the things I have written behave in the way that I believe it should behave. Not how the customer thinks it should behave, but how I think it should behave. And CD does the other side of that equation, which is it goes, you've written a whole bunch of stuff, and I've got my BDD type tests here, which talk about functionality and things that I want to see. And this gives me those confidence that those things work. And that's what these functional tests are looking at. So these integrated tests, functional tests, are kind of multi-component. And so I would look at that as, when I wanted to run one of these, I would stand up a whole new version of MYOB. Like this would be the goal that we should be aiming for. So we can stand up a whole new version of MYOB, drop in my new service or new component, and run my world tests. And when I do that, I know it's all working as expected, and I know then at that point in time it is safe. My customer can then make those choices. My customer, my product owner can make those choices and go, yeah, this is good. Our cadence is right. It might be every 2 months that we decide to release a new version of a piece of desktop software or something or another like that. The other advantage of always being able to deploy is what? Yep, that's exactly right. You've got a security problem, heartbleed, any of those sorts of things. If your software is ready to release at all times, then you're in a position that you can do it, and you don't need to do what you see traditionally a lot of hotfix branches and trying to get that stuff back onto mainline and things like that. If anyone has been in that position where you get hotfix and then another one and then another one, and then trying to get them all back in while someone else is actually working on development, it's an absolute nightmare, and you nearly always screw it up. Not because we're bad, but we're humans. We're just really, really awful at being able to organize that stuff. So if your code is ready to release, I don't need a new branch. I just create another new release in a short period of time, and I have the great confidence that it's going to get ready to go. So this to me is the key difference between those two parts of our systems. We may use the same technical infrastructure to do this. We may use Jenkins, we may use BuildKite, but they are two different things with two different purposes. Don't conflate the two of them. And this is where the problems start to occur, is when you go, I want those two things done in the same way with the same time. Because then the feedback to the developer is 40 minutes to 2 hours again. And in a team of 3 to 4 people, that means the entire team gets 4 check-ins a day, something like that, by the time you actually run on it. That doesn't seem like a lot of work is capable of being done, or a lot of safe work. And for me, it's all about safe. So, to Edward's point, I like CI. I think that's pretty clear what it is. I actually think CD is something that is not a very useful term to use because it's too easily misunderstood. So I'd like to try and think about this in terms of continuous testing, which more describes the capacity of us to set up infrastructure so that our software is always ready to be released through this process. So we do run testing all the time on these things. And then of those things that are tested, we can choose to deliver and deploy into production. I think Jez Humble uses the phrase continuous releasing or something or another like that for this. I don't know, I don't really care. I would just like people not to use continuous delivery, continuous deployment, because I think it's overloaded and too easy for people to get and do the wrong things. And I'm seeing it happen a lot in Melbourne at the moment. People are setting up a CD pipeline. Well, what's this doing? It's pulling stuff out of Git and there's no CI part of it. Oh, the CI is the first 3 stages. Well, that's useless. Where's my feedback point? Where's my failure points and things like that? So the things that become very valuable if you can logically break this up is you've got ready to delivery to actual doing the delivery. And that's kind of nice because then I can have a whole bunch of assets which might be numbered, versioned in some meaningful way here that I can choose to deploy into whichever environment I may like. So it gives me the opportunity to take a packaged creation from here and deploy it. And that's kind of really nice too. I might have a new environment that I want to test, a beta test environment or world. How does my software work in that world? Okay, I can just grab one of I don't have to set up a new pipeline to start from the beginning to do this. I can take one of my pre-prepared packages and get it in there. So the things that happen in this deployment part is the target environments, the configuration that's necessary for that. This is about creating those packages to do that. That's all I really wanted to talk about. I don't know if that made any sense or that helped. I see those 2 different things, poor testing and conflation of CI/CD deployment being some of the major anti-patterns that I'm seeing here at MYOB. We're no different to a lot of other places, but I'm here, so I care about us fixing our stuff. I think we're well on the journey to it, but certainly one of the big things I would love all of the crews to do is get your CI builds under 2 minutes. Do everything you possibly can to get them under 2 minutes. And building your software right and the testing for it right is probably the main key to make that happen. Thank you all. Questions? Running away? Do whatever.
Questions?
Those slides be out with those links in the
Yeah,
back.
I'll give them to you. Whatever, that's easy.
They're up on Slack or something.
Yeah, I can do that. That's no dramas.
All right, thanks guys for joining us. Thanks, John.
That's all right. I'm sitting over near Andy. You can come and find me and talk to me. You can disagree with me. You can yell at me. This is all good. I enjoy it very much. Thank you very much for allowing me.
Just a side note.